Presentation of the work. Could a conversational AI identify offensive language? The work was prepared by Daniela América da Silva, Henrique Duarte Borges Louro, Gildardo Souza Gonçalves, Johnny Cardoso Marques, Luiz Alberto Vieira Dias, Adilson Marques da Cunha, and Paulo Marcelo Tazinafo. All authors are from the Brazilian Aeronautics Institute of Technology, and this work was submitted to the journal Information. At the present time, artificial intelligence algorithms are used for many tasks in a variety of domains. A crucial area in AI is the natural language processing because it models how people share information and how to build systems to keep conversations with humans. Recent applications of AI have improved the accuracy and efficiency of conversational systems and driven the commercial success of voice assistants such as Amazon Alexa and Google Assistant. But could a conversational AI identify offensive language? That is the question of this work. In this work, I want to know if it's possible to develop a conversational AI to identify offensive language designed for reliability and justice and geographical area ethical issues considerations. This is like developing identification of offensive language in social media because conversational AI uses a spoken language understanding model that transcribes the speech to a text script, and therefore the text script could be used to identify offensive language, considering also bias and discrimination. So to find out, we needed to investigate in 5 steps. In step 1, we need to know if AI could be ethical. It was identified the contributions from multiple classical ethics in the development of the systems, and also the global and regional preferences and cultural clusters in the use of systems. There are 3 important measures in system development: transparency, responsibility, and awareness of misuse. In addition, there are also around 35 guides developed since 2016 related to the design of autonomous systems, segregating by contributions from civil society, government, intergovernmental, private sector, and multi-stakeholder. In step 2, we needed to know which type of bias and discriminations could happen in AI systems. Algorithms are used differently than human decision makers. However, frequently people assume that algorithms are objective and error-free. Also, algorithms are often cheap, used at scale, and more likely to be implemented without process in place. Since humans are biased, many people may think that bias in algorithms is not a problem. However, machine learning algorithms can amplify bias and create feedback loops not always consistent with the reality. In step 3, we are interested in examples about how to measure a fair ML. Fairness in algorithms is important to support human values, identify strengths and weaknesses of the system, and also track algorithms improvements over time. It's hard to come up with a single definition of fairness because there is no single agreed upon measure for discrimination and unfairness. In step 4, we are interested in understanding the opportunities and risks of the capabilities of language models. Conversational models are based on foundation models, which is trained in broad data at scale and can be adapted to a wide range of tasks. The foundation models are based on emergency, meaning that the behavior of the system is implicitly induced, and homogenization, meaning consolidation of methodologies for building ML. However, homogenization of foundation models has the potential to amplify bias and injustices rather than distributing them in addition to increasing exclusion. Some of the critical areas are mass data collection and surveillance, concentration of power, fuel widespread in decision making, between others. In step 5, we study the specific characteristics of offensive language. Language models could be used to detect hate speech and with a good accuracy using a few-shot training. However, it's not clear how those models are dealing with bias and discrimination. Several companies have used AI to assist in their monitoring policy. However, there are challenges on automated hate speech detection in separate hate speech from offensive language. In addition, an algorithm can bring accurate results in technical tests, but still cause dissatisfaction for humans. Using also human moderators is a challenge because human moderators can also react differently when labeling text. If regards to the method applied, in our previous publication, a hybrid dictionary model for ethical analysis, we proposed a model based on a dictionary for offensive language detection in 12 categories. Some of them are drugs, pedophilia, rape, weapons, racism, homophobia, defamation, between others. For the construction of the dictionary, it was proposed to identify straight from internet the words found directly on the sites that could contain offensive comments, and then classify words commonly used in each category. The dictionary was divided in 4 parts. Part 1 provides an analysis of internet issues. Part 2 provides analysis of common expressions for each category. Part 3 provides spell corrections. And Part 4 providing a content removal policy. The dictionary template is not an NLP algorithm, but a process for sorting comments that may contain offensive language using a word filter. It is also inadequate to the task of identifying offensive language because it operates at the level of words without any context. To indicate which words are offensive, the labeling process was used. However, it may depend on cultural factors, and this method only considers Portuguese. Also, relying on a human to double-check the words flagged by the dictionary would completely break the conversational flow and render the chatbot or conversational AI useless. To verify the results the dictionary could propitiate, it was applied to a text, in this case Twitter posts, clarifying that this is a low-level proof of concept. A database was created to store the dictionary from the number of occurrences of words in a text from a list of sites that contained content on categories considered offensive language. Words with the highest number of occurrences were grouped by category. It was possible to prepare a template with 12 categories and around over 13,000 words. A program built in Java language was executed to collect posts from Twitter that could contain offensive language. The program was composed by 3 parts. Part 1, initialization. Part 2, capture posts and creating an occurrence in the database. And Part 3, classify the phrase in one or more offensive category. For the experiment, the collection of tweets was carried out from 31st October 2019 to 1st November 2019. Considering that Twitter provides 1% of the messages, it was collected over 25,000 occurrences out of a total of approximately 2 million tweets. From the sample, over 7,000 posts were considered as comments with words that could be related to offensive language. Also, to provide an example describing each category that could involve offensive language, it was prepared a map by concept, relation, behavior, and some of the main characteristics about the category. For example, in the category of bullying, X is bullying, Y is joke. The behavior involves insult, humiliation, psychological violence, intimidation, and embarrassment. However, bullying is no joke. Table 1 presents the occurrences that could be related to offensive language, and Table 2 the details of categories where offensive language might be used. Our conclusions describes some of the limitations of the model. It needs to adapt to cultural clusters in global preferences and additionally to regional preferences internally in the clusters. It also needs to mitigate biases in real time and handle biases not only in the data, but also in the algorithms. Furthermore, using foundation models means the models are based on the same self-supervised learning architecture and therefore inheriting the same problems related to ethics and justice. Data creation process is complex and data can contain different types of biases. Also, after deployment, those models can present undesirable behavior on subpopulations of data. At this point, it's possible to conclusively show that a conversational AI cannot detect offensive language and or unethical behavior. However, there is a need to identify offensive language and or unethical behavior to avoid potential to harm historically underrepresented or disadvantaged groups of a population. To conclude, this work presents practical guidance on how conversational AI algorithms work and the ethical issues and minimal principles for ethics and fairness in ML algorithms. My wish is science can change our future and algorithms could support human values, and we could be very prepared to identify strengths and weaknesses of the system and also track algorithms improvements over time. Thank you.